This podcast is sponsored by AppDynamics, a leader in business and application performance monitoring. Optimize app performance, increase team velocity, and drive business with end-to-end visibility, from code level to customer experience.
Welcome to the InfoQ podcast. The InfoQ podcast is a podcast focused on senior developer and architecture trends. These are the patterns and practices and technologies people leading technical delivery want to know about. My name is Wes Rice, and I chair the QCon Software Conferences brought to you by InfoQ. At QCon, we spend 3 days talking about these topics, and it's an awesome experience. I hope you can join us for one at some point. Today is a fantastic chat with Andrey Breslav. Andrey is the lead language designer of Kotlin and works for JetBrains. In today's podcast, we discuss the recent announcement by Google to make Kotlin a first-class citizen in Android Studio. He talks about language features found in Kotlin, things like null safety, type safety, even DSL support. Then we move on to where Kotlin is going on the roadmap. We talk about things like coroutines, multi-platform support, and we even talk about Kotlin native, so compiling to native. I really love this podcast, and I for one, am super excited about Kotlin and what it means to the Java developer and the community in general. I hope you enjoy this podcast as much as I enjoyed recording it. Welcome, Andrey, to the InfoQ podcast.
Hello.
So recently I was watching Google I/O, and one of the announcements that they made was that Kotlin was going to be a first-class citizen for Android. What does that mean for Kotlin?
Oh, that actually means a lot. Like for me personally, it means recognition.
Yeah.
Because many people were asking Google to support Kotlin in some way, and Google's official position is that they answer this way.
Yeah.
They add official support. So for Kotlin, it means that now those people who were sort of anxious about maybe Kotlin is not official on this platform, maybe it stops working at some point, maybe we'll have issues. Now they have an official guarantee that they won't. So there will be very probably a boost of adoption. So many more people will be using Kotlin from now on.
Congratulations. For me in particular, when I saw that, it really rose Kotlin up on my radar and made me want to definitely pay attention. So congratulations.
Thank you.
So right now, just before we were talking, I was going through building some projects with Kotlin just to kind of get the feel for it. And I was using Android Studio, particularly because of that. And so I was using kind of the current version, which is 2.3.2 as of right now, of Android Studio. And so you had to kind of go through, install a plugin, and then you had to be able to reformat kind of Java code into Kotlin. What's that going to look like as you go into become a first-class citizen with Android Studio?
From now on, from 3.0 and on, Kotlin will be bundled with Android Studio, which means that you don't have to install anything. You have an option of creating a Kotlin project from scratch, so no need to create a Java project and then convert. And then basically we're aiming at feature parity, so we'll work together with Google people to make Kotlin and Java on par on everything.
Okay, very cool. I definitely want to jump in and talk about what feature parity means. But before we do, let's just back up and kind of start from the beginning. What is Kotlin, and where does it fit into the Java ecosystem?
So basically, Kotlin is a programming language that you can write everything you could write in Java. So the point is, Java, the language, is compiled down to bytecode, and Kotlin, the language, is compiled down to the same kind of bytecode, Java-compatible bytecode. You can use all the existing libraries. You can use most of the familiar code patterns. It's applicable everywhere where the Java language is applicable.
Right. Okay. Makes sense. So you just said before you answered that you're striving for feature parity with Java. So what does that mean? Does it mean it's not 100% compatible? Are there areas that are not quite there yet?
I actually meant tooling.
Tooling. Oh, of course.
So when it comes to the IDE support in Android Studio, Java has been around for a very long time. There are many language-specific services for Java, like inspections, intentions in the IDE.
Right, okay.
So we are now unifying the linters on Android and all the other IDE services.
Of course.
So that Kotlin and Java have the same support.
But the language itself has all the features that Java does. Kotlin can do the same, right?
Yeah, so anything that you want to write in Java, you'll be able to write in Kotlin. And languages are, of course, different. But the idea of the compatibility and interoperability is that in the same project, you can mix and match Kotlin and Java code. You can call Kotlin from Java. You can call Java from Kotlin transparently with no runtime penalty or anything like that. So it's really transparent when you go from Java to Kotlin back.
So what does that experience look like when you're calling Java from Kotlin?
It looks like a normal method call or normal function call. Kotlin has the same library format as Java, the language. So you just import classes as you import them in Java and call whatever you like.
Nice. What about like types? Is it Kotlin and Java have a common type system where types can communicate across? What does that look like?
It's not exactly a common type system, but Kotlin is smart enough to sort of convert Java types to Kotlin types on the fly. It's all compile time magic, so there is no runtime conversion anywhere. So we recognize Java collections, Java strings, all Java classes actually for what they are in Java. And actually, the Kotlin compiler adds a little bit of type information on top of that.
Oh, cool.
For example, Kotlin knows about what's null and what's not null in your program, what collections are supposed to be read-only and what are mutable, so on and so forth. So we enhance the existing Java types, make them more usable and more safe.
Yeah, very cool. You mentioned earlier that with Google recognizing and saying that Kotlin's a first-class citizen, adoption will drive. A little bit of a confession. I played with Kotlin probably 2-3 years ago, but I never really adopted. I didn't start using it much. But recently I did a contract. They wanted me to use Swift, which wasn't my main language. But as I started working with it, it just felt familiar to me. And then I realized, I guess, just prepping for this podcast, that it's because Kotlin and Swift are pretty much very similar. How did that happen?
Well, I don't have firsthand information on how exactly that happened, because when Swift was announced, we looked into it and saw that it has similarities to Kotlin. Apparently, we started at roughly the same time.
Yeah.
But JetBrains published the description of Kotlin, I think, very early on. And so at least the Swift designers had a chance to look into that while they were working. And I'm, by the way, very happy when I see some similarities in different languages.
Yeah, sure.
Because I myself learned a lot from other languages. And I think it's a great process when designers of different systems can look into each other's ideas and sort of get inspired by them.
Yeah, absolutely.
So I was really glad when I saw that good people working on Swift actually learned something from Kotlin. It was great.
For me personally, I thought it was pretty cool using a language that felt pretty similar across Android and iOS. In fact, here in just a few minutes, I want to ask you some questions about Kotlin native and how we might actually be able to target iOS directly. But before we dive into that, can you give me a bit of a history of the Kotlin? How did it all come about?
We started thinking about Kotlin in 2010. So actually, people at JetBrains started throwing in ideas about a new language sometime in early 2010. And then it so happened that I was invited for not even an interview, but sort of a chat.
Yeah.
And then it was like we clicked and we had a very productive conversation about what a language could look like. So actually, I was skeptical at the very beginning. So when I came in, then they told me they want a new language. I was like, oh, guys, you're crazy. Don't ever do a new language. There's no point. There are other languages, so on and so forth.
Yeah.
They had very good arguments. And after maybe like 2 hours talking, I was completely converted, and we started throwing in ideas for a new design, and some of them actually survived. And so that was when it started. It was spring 2010. And then I think we announced sometime in 2011, and then open sourced in 2012. It was before 1.0, so it was like early preview versions. And then it took us quite some time to finalize the language design, and it was February 2016 when we released 1.0.
Yeah, just about a little over a year ago.
Yeah.
So you just said something that obviously is one of my questions too with Kotlin. So there's other languages on the JVM, of course. There's Groovy that gives you that dynamic language type support. You've got Scala that gives you functional language that removes a lot of boilerplate that maybe Java had. Why did you guys go with another language? What was kind of the driving thing that turned you over in that 2 hours to say, yeah, we should create another language?
There are many criteria there. Actually, any industrial tool has very many requirements from many sides, so I'll try to enumerate them all. At JetBrains, we were working on a Java code base for a very long time, and we accumulated a lot of Java code, and also a lot of experience and a lot of expertise in how to make programming nice for people. So we came to a point where we basically reached a limit of how nice it can be with a given language, Java. So we wanted an improvement for everybody. And there were options with Groovy and Scala. So what we wanted was something that's going to be fast, because at runtime you have to perform well. That's going to be toolable, so that it can make tools like we are used to in Java, some excellent tooling that understands your program and helps you work there. And these two already are very big considerations there, because with Groovy and Scala, even the toolability part is difficult. So with dynamic languages, tooling can't be as smart as with static languages. It's important because all the dynamism means that the compiler knows little about your program. That's why it's so flexible, but that's also why the IDE can help you in very many situations. So Groovy was difficult in that respect. They added static compilation later on, and it has its merits. But also with dynamic languages, there are difficulties with performance because dynamic calls are more expensive than static calls. And on the other hand, there is Scala, a very static language with very strong type system. So Groovy's weaknesses of lack of a type system could be compensated by Scala, but then Scala is not very easily toolable either because the type system is so rich. It's very hard to make the tool understand it and be fast. So we are working here at JetBrains on a Scala plugin, and it's been very widely used. But we know how difficult that is. It's a language that's challenging to understand for machines and also challenging to understand for very many people. And we believe in sort of democratic language design when everybody on the team can understand everything in the language. And so Scala can be challenged there. And also there are some particular sides of Scala's language design, like heavy use of implicits, for example, that's difficult inherently for understanding and support of the code base. So these were more or less our biggest concerns, and we actually did try both Groovy and Scala in production. I'm not saying they're bad languages. They're great languages in very many respects, but there are use cases that they don't cover so well, and we felt that there was space for something else. And we also felt that we as a company may be the right people to fill this space because we have the expertise in languages and we have the leverage with tools, so we can actually make the end user experience with this language great. And that's what we're working on.
Yeah, absolutely. I stuck away from IntelliJ for the longest time, and then finally just went all in and absolutely loved the experience using IntelliJ. So the idea of the same people producing the IDE that I love now, producing a language, that really excites me.
Yeah, thank you for the kind words.
Yeah, so let's talk about that. So let's jump in and talk about what you get when you decide to use Kotlin as a language. Obviously, there's the billion-dollar mistake, NPE, that Kotlin addresses. So let's talk about that and then dive into some of the other things that you get when you use Kotlin.
Yeah, so we'll start with safety features. So most prominent of those is nullable types. So basically, the Kotlin compiler wants to know which of your references can hold null and which can't. So you have to specify in your program. So here I store a string, which means that it's exactly a string, not a string or null as in Java. And here I can store a string or null. It's a little question mark at the end of the type that makes the whole difference for the compiler. But it can check that you're not trying to do dangerous things like dereference or possibly null pointer. There's also some machinery that makes it not very tedious to persuade the compiler that here and here it's okay to try to dereference because you as a human may know that it's actually okay. It won't be null there. So this machinery is very important to prevent null pointer mistakes. And also we have other safety features like the collections that I mentioned before. So there was an issue with collections in Java and JDK. They're mutable, like everything, every collection interface is mutable. Lists you can always add, you can always clear. Map you can always put, you can always clear. And obviously in many APIs, you're not supposed to mutate anything you're getting out from that API. It's just queries and they can be reused, and the collections themselves can be reused on their other side or something like that. So people do defensive copying and it's difficult, and on the performance, it has bad implications. So Kotlin provides you with a different paradigm. Although at runtime, we use the same collections, but in the type system, we have read-only interfaces and then mutable interfaces. So you can express as a type that this list shouldn't be modified here because read-only doesn't have an add method. It doesn't have a clear method. And this helps to make APIs a lot clearer. So it's like clean separation. When I'm passing this collection into something, is it going to be modified there or not? So that's another safety feature.
You also do something called smart cast, right? What's that all about?
If you do an instance of check, an is check in Kotlin,
yep.
Say if A is B, you don't have to cast after that. So in every explicit cast in the program is an error-prone thing, because if you remove the check or some logic in your program changes, then it's a potential class cast exception. And if the compiler knows when you already checked and does require an explicit cast, it means that if the check changes, the compiler will let you know that here you're trying to call something that's not there anymore.
Yeah.
So these are like the most interesting safety features. There are a number of others, but yeah, these are the most interesting.
Joe Duffy talks about some of these safeties quite a bit in his work around the three safeties. There's a blog post called The Tale of Three Safeties where he talks about the need for memory safety, type safety, and concurrency safety. I think you just hit on some of the concurrency and type safeties with Kotlin. Can the language do anything to help with things like memory safety?
Well, it's nothing specific to the language because we sit on top of the JVM, and JVM provides some memory guarantees. So there we have nothing really. So for the JVM, Kotlin native will definitely have some sort of a memory model, very probably a more relaxed one than the Java memory model. But still, there will be some memory safety guarantees, memory consistency, and everything, yeah.
Okay, cool.
Yeah, well, definitely like to prevent buffer overruns, for example, but it's not very important.
One of the things that really stands out for me as I looked and explored Kotlin is that it really seemed to me like there was a lot of thought put into the readability of the language. I mean, it felt a lot like the language was almost a DSL, or at least you could create a DSL very easily, like it was a first-class concern as you built it. Is that fair to say?
Yeah, it is. It actually is. We were looking into other languages like Scala and Groovy, and C# is not that relevant in this respect, but some others too, Ruby, for example. And they have excellent DSL capabilities. So we thought about different ways of adding similar features to Kotlin in a clean way. And I think we succeeded. So basically, the most interesting part about Kotlin DSLs is that we can do what we call type-safe builders. So basically, it's something that looks like declarative code. We do HTML like this, or build scripts, for example. The new Gradle scripts can be written in Kotlin.
Oh, wow.
It looks like declarative code, but what it actually is just a bunch of function calls in Kotlin. And Groovy can do the same, but it's like very dynamic. There is no type checks there. And we figured out a way of doing mostly the same things, but in a type-safe way and with no dynamic runtime support. So it's just very straightforwardly simply calling functions with lambdas, and that's it. So that's been heavily used in very many applications, from build scripts to building UIs. So it's been a good idea.
Yeah. There's some features like trailing closures, like trailing lambdas, I guess in this context, that kind of support this feature, extension methods that kind of allow you to do this. But when you put all these things together, it looks really clean. Can you walk through some of like what extension methods mean for a language, particularly for like the Java folks out there, and what this idea of trailing closures kind of looks like in practice?
Okay, so trailing closures will be easy, so I'll start with those. So it's a simple language convention, actually borrowed from Groovy too, where if you have a function that takes its last argument as a lambda, you can write this lambda outside the parentheses. So you can say my foo that takes a lambda, then you don't say foo parentheses, then curly braces for lambda, then parentheses closed, but just say foo and then a lambda in curly braces, and that's it. So that's pretty straightforward. Extension functions are more interesting. So we are all used to extending classes in object-oriented programming, where you can have a soap class and there add a method, for example. But that basically requires you to create a whole new class to add some small thing. And at runtime, if you already have an object of another class, you can't add a method on that object. So this basically means that only one person or only one vendor can design an API of something. If a library has a class, a string in the JDK, there's no way you're adding a method onto that. And there can be specialized libraries that want actually to add some domain-specific method on a string or on any other class out there. So what we did in Kotlin was something initially introduced to mainstream in C#, where you can define a function that when you call it, it looks like a method in a class, but actually at runtime and in the bytecode and everywhere, it's just a static method in another class. You just say, okay, this static method looks as if it was a method on that class. And then you can say any string dot my function. So that's about it. So technically, it's compiled down to the same static function as any like stringydeal class, but it looks and works in the IDE and reads as a method in a class.
Yeah, then there's also with a single parameter in Kotlin, you can drop it and just reference it in the method. So if you put all three of those things together, you can create, and I think you did a demo of this in at Google I/O, but you did something like where you took a variable that was like user.filter, then had some block of code that was a closure that was running, or a lambda that was running, and then sorted by with another lambda, then .map with another lambda, and it just made this like really clean filter, sort, map kind of DSL type expression that was really clean to look at.
Thank you.
So a lot of languages that I hear about today, like Go in particular is what I'm thinking about, are super opinionated. So there's like this path on how you develop things. What is Kotlin's take on being an opinionated or not an opinionated language?
I would say we're sort of trying to find a balance here. There are famously opinionated language, Go, that you mentioned, and Python. So their philosophy is the one way to do this, whatever that is. Well, it's a good idea, but it has its limitations. So opinionated languages tend to be small, and this is good. They're easy to learn. But also it sort of limits the number of convenient features you can add into the language. And I don't think that it's a good idea to add like every thinkable feature to the language for everybody's convenience. But it seems that more widely adopted languages are a little bigger than the opinionated ones. So we're trying to be reasonable there. We are very skeptical about adding new features to Kotlin, but we are adding them because some features are good enough to be added. And it takes evaluation, it takes design, it takes a lot of criticism before a feature is added. But we are not trying to be like super strict. There must be only one and only one a way to do any one thing. So we're trying to be pragmatic there. Actually, pragmatic is like the biggest word in Kotlin's philosophy. If something is inconvenient and we have to step away from our opinionated position to make it convenient for people, and it's important, we'll do it.
Nice. Well, since you brought up the point of adding new features to the language, it seems like a good time to start talking about some other things. So you've got some other things that you've been working on. Coroutines come to mind, some LLVM stuff that's going on. So let's talk a bit about that. First off, what are coroutines and why are they being brought into Kotlin?
Okay, so coroutines, the very term originates from deep and dark computer science that I'm not going to talk about. But the idea there is that we wanted to make writing asynchronous code easy, and I think it worked out. So the goal of coroutines was to take away from all of us the pain of writing asynchronous code explicitly. So when an asynchronous program works, what you're trying to do all the time is you have this call, and you don't know when it finishes, but your logic depends on this call. So you pass a callback into that, and when the call is done, like when you receive the data from the network or something, that callback is then invoked. Then want to make another asynchronous call, it will be a callback inside a callback inside a callback inside a callback. Yeah, and if you Google for callback hell, you'll see some nice pictures about this. So it can be really painful. So the idea of coroutines is to make asynchronous programming as straightforward as traditional sequential code by basically automating all this callback passing and taking it inside the compiler. The result is that you write asynchronous code in a traditional way. You can use all the familiar constructs, ifs, whiles, fors, breaks, and continues, anything, try, catch, all the standard things. And what you get is the code that reads as usual, doesn't have any intricate control flow. So it's understandable, it's maintainable, but it actually works asynchronously. And also coroutines. So coroutines are good for many tasks that are traditionally done with threads. So basically, they are like very cheap threads, almost free threads. So the idea is that you don't have to block a physical thread to suspend a coroutine. Coroutine is suspended in a very lightweight way. So you can, for example, start 100,000 coroutines in parallel and do some work in them. While even if you try to start 100,000 trivial threads, they won't fit into memory, basically. So it's like the easiest way of thinking about this. First, it's a way of doing asynchronous programming. Second, it's mostly free threads for all of us. So it's scalability and it's easy to write and read code.
How does the coroutine implementation in Kotlin compare to things like async await in C# or maybe Go routines in Go?
Yeah, so basically Go has gone even further than Kotlin did because they have coroutines not only in the language but also in the runtime. Among the JVM languages, Kotlin is the closest to Go, but we are not there yet.
I got you.
So the whole paradigm was popularized by C#, I think, with async await. And the difference between Kotlin and C# there is that we made it like super flexible for library writers. So we don't have keywords in the language for async and await. We can express async and await with coroutines as a library, and many other things can be expressed as a library, and that was an explicit goal. On the language side, we're a lot more flexible. On the semantic side, it's mostly the same. It's only a language level difference. So we knew all this, but it was a challenge to fit this all into the clean language design with no huge syntactical overhead of specifying everything, so on and so forth. So we actually ended up adding only one modifier, which is not even a proper keyword. So it's like super little on the language surface.
Coroutines isn't the only thing that you have going on with Kotlin, right? For example, we've been talking a lot about the JVM, of course, but you also target a JavaScript VM, right? You even hinted earlier about a compile to native ability. Can you talk a bit about Kotlin support for native and non-JVM runtimes?
Yeah, so we support JavaScript. It's been released in 1.1, so now we can compile Kotlin to JavaScript source code and run it in the browser or in Node.js. And that's ongoing work. We are working on the tooling there and improving the runtime and so on and so forth. But we also have already started Kotlin native, which is a separate effort. Basically, we're using LLVM to compile Kotlin down to native code. So we produce standalone executables that don't require any virtual machine or anything. And that's a very ambitious project because we want Kotlin to run on every platform. Where a VM is available, you use the VM, JVM, or JavaScript VM. Where it's not available, you compile down to native. And it can be even small devices like microcontrollers. If LLVM supports that, we can do it.
Very cool. What kind of devices are you planning to target?
So currently, we can do, for example, of small devices, Raspberry Pi, but we're going to target smaller devices as well. But of course, it's not only for small embedded systems. It's for iOS, for example, or for just Linux machines where you can do command line tools or microservices, so on and so forth. And we are going to support Windows pretty soon. So it's going to be available on as many platforms as we can. And it's an explicit goal because the next step will be to have Kotlin code shared between different platforms.
Sure.
You can write a full stack application where both the server and the client are written in Kotlin, and the language and the tool chain will provide you with some aids to do that. Or you can, of course, share the same sort of code between your server and all kinds of clients, both web, Android, and iOS, for example.
That's really cool.
There are many interesting things. And mobile code reuse alone is a very interesting story when you can share business logic between iOS and Android, for example.
That's very cool. So what else is on the roadmap that's coming up with Kotlin?
So these are like the two big directions we're working on right now, coroutines and multi-platform projects, like sharing code. And then if we look further, there is an interesting question of how we do meta programming in Kotlin. Because we, of course, have reflection. We support annotation processing for the JVM at least. But some people already request macros, like we want the full power of customizing everything in the language. We're reluctant to doing this for one reason. Tooling will be very difficult. So languages with macros are very, very challenging tooling-wise. So we're looking more into compiler plugins or something like this. And there are interesting ideas there. But it's not on the immediate roadmap, so it will happen sometime later. But we realize that it's needed.
Very cool. Well, Andrey, I'm sold. Kotlin sounds like a place where I'll be spending some quality time over the next few months. Thank you for bringing us Kotlin, and thank you for taking the time to chat with us on the InfoQ podcast.
Thank you for having me. It was great to talk to you.